So we left off in the last video with the results of that pay-as-you-drive randomized experiment in the Netherlands, and we looked at the various components of the basic components of an experiment, which are represented in this diagram here. Now, I just wanted to point out that we're going to take a little closer look at what it is that random assignment actually achieves. So these young drivers were recruited, and just by the flip of a coin, they were randomly assigned to the pay-as-you-drive type of insurance or the more traditional fixed price insurance, and then their behavior was observed over a several months time period. So now notice that the choice of insurance, the type of insurance that they had, was not a choice of theirs. They didn't choose the type of insurance. Safe drivers didn't pick the pay-as-you-drive insurance, and risky drivers avoided it, or it wasn't a matter of their economic status or their awareness of the risks of dangerous driving or anything like that. The assignment of the pay-as-you-drive insurance was totally random, and that makes the program, this treatment, it makes it exogenous. I mean, in many ways, that's the very definition of exogenous. It's a variable that applies to this group but does not apply to this group, but is totally unrelated to any other variables that describe either group. So it's not related to their driving habits, it's not related to their knowledge of insurance, it's not related to their ability to pay or not pay, and so on. So random assignment makes the treatment exogenous, and random assignment makes the two groups equivalent statistically. And so it allows those two things, that we know the treatment is exogenous, we know the groups are equivalent statistically. And then, so to summarize, random assignment ensures exogeneity of the treatment. So it ensures that the treatment is exogenous and not self-selected. So the treatment is applied only on the basis of a random number, a flip of the coin, as it were, and not because of any other motivations or needs or abilities that might also influence the outcome. So the treatment is exogenous, and random assignment creates statistical equivalence. So it produces a control group and a treatment group that are equivalent for all variables, and that includes both measured variables, things like age and education and race and gender, and things that are relatively standard measures and ways to look at the control group and the treatment group, but also in terms of unmeasured variables, things like motivation or tolerance for risk or personality, or things that the many kinds of things that kind of can be unobserved variables that confound evidence in observational studies. And so let me just explain a bit more about what exactly statistical equivalence means. So it doesn't mean things are exactly alike in treatment group and control group. And here's some real data from a randomized study in which some data we give in the book, which shows how the groups are, the treatment group and control group compare on a couple variables. So here's, this is if you remember from the example in the book, it's a welfare to work program. And so relevant variables would be things like education, how much education the treatment group has and the control group has on average, how old they are, and how much work experience. And so those are all things that could determine someone's employability and so on. So, but notice the means are not exactly the same. It's 11.6 compared to 11.5. It's 34.5 compared to 34.7. It's 7.7 years of work experience compared to 8. They're not exactly equivalent, but they're statistically equivalent, meaning that these differences are not larger than what would be due to just chance variation. So since you randomly put some people in the treatment group and other people in the control group, there are going to be chance differences, right? And so these fluctuations are what you would sort of expect from chance, and none of these differences in means. None of these differences in the mean or average level of education, none of the differences in the mean or average level of age, and none of the differences in the mean or average years of work experience. And none of those differences are statistically significant. They're only chance variation. So that's what's meant by statistical equivalence. There's no, they're not exactly alike, but they're not any more different than a group you would expect from a group that was randomly formed, right? So that's just kind of evidence and gives you a sense of what the meaning of statistical equivalence is. Here's another way to look at it. This is maybe a little more complex, but there was a random number used in the study to assign people to the treatment group and the control group. And here are the variables: age, education, work experience. Another way to look at it is the random number that was used to assign the program or the treatment is totally uncorrelated. These are correlation coefficients, uncorrelated with education, age, work experience. And since the random number is what determines who gets the program and who doesn't, it means sort of because these correlations are all close to zero, again, at least in a statistical sense, they're not exactly zero, but they're close to zero, and only vary from zero in a kind of random way. That the treatment is uncorrelated. The treatment is uncorrelated with education, uncorrelated with age, uncorrelated with work experience, and that's another way in which to think about the notion of the treatment being exogenous. It's unconnected, uncorrelated with these three variables, but also uncorrelated with any other variables we could probably think of, except for what might be due to chance. I mean, there are sometimes some chance correlations that pop up, but they're generally not going to be very large. Okay, so now let me make a point. So about statistical significance in an experiment, because it has a particular meaning. Statistical significance tests really do have a meaning in experiments, and often they don't have such a clear meaning in observational studies. And that is that if you think about it, a statistical significance test is a test of whether the difference between the control group and the treatment group is due to chance or to something greater than chance. So a statistically significant result is a result in which the difference between the treatment group and the control group is greater than what you would expect by chance. And when we're looking at all of those background variables, there are no statistically significant differences. But if we look at the outcome, like in the case of the pay-as-you-drive study, the rate of speeding, the percentage of the time that the drivers in the treatment group were speeding compared to the percentage of time that the drivers in the control group were speeding, that difference was statistically significant, meaning it was a larger difference than was due to chance. And that has a real meaning because we assign people, the young drivers were assigned to the treatment group and control group using a random number. They were assigned by chance, right? And so if the difference in their driving, their speeding behavior, if that's greater than what would be expected from chance, and in fact it was much greater than what you would expect from chance. I think the p-values there were on the order of 1%. So the difference that we saw in that graph would only happen by chance, one time in 100, right? That's the meaning of a significant result at the 1% level. Then because we've used chance to assign people and it's not related to any other variables, it must be related to the treatment, which is the pay-as-you-drive insurance. So that must be the cause. So one of the lessons here is that no statistical significance test on its own can ever prove causation. It's not the statistical significance test that proves causation. It's the significance considered together with or combined with the overall design of the study. So when a researcher uses a randomized experiment, they're using chance to allocate the treatment. And then if the difference between the treatment group and control group is greater than what you would expect by chance, then you know that the treatment must be, or at least it's likely to be, the cause of the difference that you observe. Okay, now we're going to think a little bit about some of the settings of randomized experiments. There are really a great variety of randomized experiments. They come in all shapes and sizes, like many studies, like surveys. There can be small surveys and big surveys and online surveys and interview surveys and so on. So there are various kinds of experiments, just like there are various kinds of surveys or other sorts of studies. And one way to characterize the different types of experiments is the settings in which they occur. So some experiments are lab experiments. They take place in laboratories or specialized settings in which researchers bring people to a laboratory, often because they need to use specialized equipment to measure behavior or thought processes or brain scans or all kinds of things, reaction times. And so some experiments take place in the lab. Other experiments take place in the field, in more natural settings. So field experiment refers to settings that take place in the real world, such as schools, businesses, and neighborhoods. And this pay-as-you-drive study is a field experiment, because it was an experiment that looked at people's real driving behaviors in the real world. And so that's an example of a field experiment. By the way, there are some interesting examples of safe driving experiments that are done in the laboratory with, driving simulators. There was some interesting studies, I think we mentioned in the book, about texting and driving. And obviously you wouldn't want to encourage people to text and drive in the real world, where they could have a real accident and either hurt themselves or hurt somebody else. So researchers studied that in a laboratory with a driving simulator and had people texting, and they observed their behavior, their driving performance when they were texting versus not texting. And so obviously some things you shouldn't experiment with in the real world because it may be dangerous to the participants or other people. A final type setting for an experiment is a survey experiment. So this is might seem kind of contradictory at first, but surveys are a way in which surveys are often used for observational studies, but there are ways in which you can experimentally manipulate the parts of an experiment. So some of the earliest survey experiments were question wording experiments. So for example, you can vary the way in which you ask people about whether they voted or not. And it turns out that if you kind of mention an excuse, like if you give people the idea that, well, not everybody has the time to vote, and sometimes elections in your district may not be that competitive. Okay, given that, in the last election, did you vote or did you not vote? And if you give people, if you ask the voting question that way, it turns out that people will more likely report not voting, or they are less likely to over-report voting. And if you just ask the question in a more straightforward way, did you vote in the last election or not, then people, because of social desirability bias and especially in interview surveys, the desire to appear kind of to be a good citizen, people will over-report voting in that kind of question wording. So the earliest survey experiments, and they're still used a lot to test out different ways of question wording. So half the participants in the survey get one version of the question, half get the other, based on sort of a random assignment, random number, or flip of the coin. But they've expanded beyond that. Survey experiments have become much more sophisticated, especially with online surveys. So people can be shown images, they can be given scenarios or tasks to do, and a great deal of experimental research is now being done online via surveys, particularly web-based surveys, which embed different kinds of information or different kinds of treatments that at least can be experienced sort of visually online.